Okay, it's a Tuesday morning, March 18, 91. This is the Freeman Diversion project. It's rained the past 2 days, a total of about 4.2 inches in Santa Paula. The river's flowing pretty well here. And that's the diversion structure proper, built to stabilize the Santa Clara River and establish a fixed point of diversion for the United Water Conservation District. Let's take a close-up here. We can see the little jump the water takes in the middle of the structure. That is focus here. That's due to RCC overbuild. The structure is built out of roller compacted concrete. From the crust there, it's about 60 feet deep to bedrock, although the fall is only 8 to 10 feet there. Pan out and take a look at the day while we're here. It's a beautiful sunny day. Clouds are obscuring the mountains. There's some snow up there. Quite nice. So 126 freeway in the background. Panning over to Limonera. And back downstream from here. Of course, the Pacific Ocean is about 5 or 6 miles down. The water that runs by, of course, has gone to the ocean, and what we do with our diversion is spread it in recharge ponds as well as direct irrigation deliveries. I guess I wasn't focused there very well. Hard to say. Thanks. Whoa! This is the crest of the structure. Spilling. And we extended a new berm and riprap back upstream and tied into an existing levee at that point there. We also constructed one that runs perpendicular right up in that area, this side of that windrow of trees. And this keeps the river trained over the structure, because the riverbed downstream is going to continue to fall. Down to the ocean. And likewise panning upstream. These are safety stop signs that we installed. Normally the riverbed's dry out here, and the dirt bikers and four-wheel drive enthusiasts get out here and get scooting down this river and wouldn't see the structure until they were airborne. There's upstream. The Sesame Creek drains from the other side of the Horizon Mountain on the left, and the Santa Clara River runs pretty much right down on the right, stays hugging the mountains. So what our diversion work does now is we maintain a flow over on this right bank. Well, right in this picture, technically the left bank of the river. And we divert through that facility there, which is a trash rack to screen out the debris from the river. But also, we maintain a sluiceway, which is this water coming down here beneath my feet, huge gate, a roller type gate, and in turn runs down this channel. That's some pretty rough stuff. Now we're flowing supercritical out the bottom of this gate, of course. It's a little noisy. Let's see if I can get a picture of the hydraulic jump here. Right there. Our water's jumping. Zoom in on it. Probably 6 feet deep. So it looks like a little sheet of water, probably 6 feet deep. Structure and again down below. Back again, we're right down at the river on left side of the channel. You can see the lovely chocolate brown nature of the water. I'll show you some facilities for dealing with that later. The tape. This piece of concrete you see is the very upstream-most portion training wall, leftmost training wall of the intake structures. There's the existing farm levee. That over there, excuse me, about to fall off. That over there is the future jail site for the county jail. The stop signs I mentioned earlier. The water disappearing over the horizon. Gotta watch our step here. And in the shadow, there's the sluice works. That's where we were just looking right down. I was standing right on top there. Here's how the water handles that corner. That wall comes down at a steep slope to the same elevation that the crest of the structure is at, and then projects out our direction to the point at which I'm standing. And this is the trash rack here. And our diversion flows are taken out through there. I'll walk up this wall now and take a few more shots. Yeah, there's a better place. So I was standing right on top of those structures in the earlier shots. The water going through there is bypassed down that sluiceway we saw with the critical flow, or supercritical flow rather. This is the trash rack. There's a component of the water is flowing into this structure. Those tines that you see operate on chains and run between the bars and can automatically turn on and lift debris that gets impinged like that. They can see how they can pick that stuff up, and they run all the way to the top of the facility, the mechanism there, and dump on over the back onto this elevated slab, where it can be handled by equipment. Here, we'll walk around and see that. Side of the trash rack, and there's a loader that they use to deal with the trash that dumps on the slab. Pan back a bit. And those tines go up over the pulley there at the top and then slip between those rubber mats, which scrapes the lion's share of the debris off them. And there's the river, and that's where those previous shots were taken. And it's going to be in the sun here, but I wanted to get a picture of the debris. I hope this is coming out. The camera's acting funny. That's debris from the last couple days of storms. They had some good rains a couple weeks ago and had about twice that much. It's been a dry year. This 90-91 water year was completely dry, except a couple inches off and on until the month of March, and you had incredible rainfall by then. Standing clear up on a small levee on the left abutment in South Mountain, and there's the diversion canal downstream of the trash rack. This isn't really all that interesting, but it is the hydraulic operator for the trash rack, and all those hoses run out and drive individual units, banks as it were, of those tines. The trash rack. We've got the sun in us here a little bit, but I'll try and swing over here against this railing. And not too much debris. I think it's all blown by in this high water. I think the water's crusting the structure over there by 3 feet and is on the receding limb. Seemed to have peaked about 6 this morning. And of course the main component of the flow is perpendicular. Working. Every time I turn it off, the camera won't turn back on. I don't know exactly what I'm doing wrong. This is the little area right inside of the trash rack. In fact, if I slowly pan over, you'll see what I'm speaking about. There's the operator and there's the trash rack again. So the water flows right under this elevated slab into this area and through those 2 gates, which are drowned out from this side. We'll show them to you around the back side here. Now there's another interesting gate on the other side of this tractor, which I'll talk about in a sec. Here operates the fish ladder, which is a requirement of the project. There's a history of migratory steelhead trout in the Santa Clara River, and of course when we build something like this, we have to let them get up around it. So we did that with a pretty interesting structure. It was on the other side of that flushing channel, which is right there, and this is the fish ladder. And I'll try and take some shots of it here. Looking straight down and even back a little, the water through that gate enters the upstream portion of the ladder right there, and then it runs through sets of baffles to maintain the appropriate headwater elevation. Those are orifices rather than baffles, I should say, because once it gets down to this area, it gets steep and runs down sets of baffles. It's called a Daniil type ladder. It's a set 4 full and 1 short Daniil ladder in switchback fashion, and the fish would enter through those gate risers that you see in the upper part of the picture, go to gates which are down submerged in the river out there to the right in this picture, and they would enter this ladder and be able to swim up these switchbacks and get up around the structure. Up at the orifice section of the fish ladder where we were looking straight down before, and we're looking upstream now, down at a lower elevation. This facility right here in the foreground is a power pump to supply cleaning water to a system of fire hose type risers that we can use to clean off some of the other facilities. Closer shot of the water coming down the fish ladder. Pedestrian bridge for access. And here's the only ladder that doesn't appear to be drowned out, is this very little short stretch at the top. The water flows down underneath my feet where I'm standing, takes a turn and is heading down underneath this catwalk through the baffles, and then is drowned out down in the following ladder sections. I'm going to pan around here and show some close-ups of some facilities I'll take some better shots at. This extra goodie here at the end of the ladder is auxiliary flow facilities, which aren't currently operating, but were they operating, water would be coming out of this pipe and flowing through some baffles underneath us here, and back out the same gates that the fish would enter down here. We'll get a better shot of this. Okay, here's a good vantage point of the fish ladder. Okay, we were up looking at that gate up there, and we were standing right near that gate and looking down at these orifices. And like I said, the water turns, follows that ladder down, turns, follows this ladder down, but the rest is all drowned out. Ultimately, it's exiting it through a slot in this wall right into here below where we're standing, and then exits through the concrete wall on the left, which is where the fish would enter. And again, the auxiliary flow facilities would be through this direction. And while I'm at it, I can show you where that pipe starts is over there at our diversion canal. Using my eyepiece here. Through these facilities. And that gate turns water into the structure. Here, the pipe is under the ground. So right there. And then straight below us and out to the river. Let's pan on over to the river to the upstream side again. Diversion canal. Canal gates. Fish ladder and the flushing channel. This is probably a good spot to look at this flushing channel. Try it this way. Point of view, photography. Hope I don't drop the camera. I don't like holding it like that. There is better. Get the picture out. Look at that. Some water. Get those kayakers in here. And the rest of the structure. And on down to the ocean. The gate operator is the fish ladder. These pair of gate operators is the fish ladder entrance, as they call it, where the fish would come in. Yeah. Yeah. Ray's taking a fish sample. This is Ray Ball here. Operator of the facilities. He's grabbing some of the dirty water to determine how much polymer they should be injecting at another facility. I'll take pictures of in a minute here. Downstream of the canal gates, and the water entering the fish screen area, as well as getting the adult migratory fish up over the diversion. We were likewise required to keep the ocean-bound juvenile fish from being entrained in the diversion. And this is the screen, currently not functioning, drowned out with water. We got a lot of problems with this screen. It's hard to visualize now, but it consists of 50-some panels with 3 32nd-inch holes drilled in them, staggered. The idea being to keep the fish in this area here where we can deal with them down at the downstream end. I'll talk about some of the problems here. Let's see if I can get a better vantage point first. Get a view of the screen. 54 panels. These 4 at the end that are open are trip panels and fail when the screen becomes clogged, and you can see all 4 have failed and the water's gushing through there. Big part of the problem is these screens are wiped by brushes which clean the clogging debris from the pores, and the motors that drive these brushes appear to be underpowered. The screens become clogged and these things fail, and they failed at moderate flows at less than 100 second feet, and you tighten them up and it still failed. The district's water right is for 375 CFS, and that is about what we're diverting here. The operations guys are wasting a little downstream, which is not normal procedure. Wrong with this camera, but having some difficulty. Again, there's another view of the fish screen. You can see the jets of water coming through where the 4 trip panels are down. The operation isn't quite the way it was envisioned here, and we're going to do something about it. But in the meantime, they're diverting in more into this area than they probably ought, and they're drowning out the fish ladder. But the darn thing fails anyway, so it doesn't really matter. Were it to be working, the juvenile fish would be on the far side of that structure, trapped and unable to get through to the canal area. There's 2 facilities right in this area, which is for handling them. One is a bypass where we can spill them over a weir gate, run it down a pipe that runs back right underneath that Bronco thereabouts, and hooks up onto the fish ladder and dumps them out a pipe back into the river. I'll show a shot of that in a second. The other is a trap facility, which is this box with that ladder going down into it. I'm going to walk over now and take a closer look at that. This is the trap. You can open that gate and put a lot of water through here. The fish come in and get trapped in here, as that there's this tight screen right there that they can't get through. They can then be netted out of this area, put on trucks, and taken to the Santa Clara River estuary. We're trying to initiate negotiations with State Fish and Game to handle that part of the work for us, and those should be pending. Of course, this gate leads back out into the canal. And our canal down to Savacoy Sprinting Grounds, through some other facilities that I'll be talking about. Pipe, because it's submerged right now. This is the fish juvenile bypass pipe, runs right about in there and dumps them into the water there. This stem here is the gate operator. The gate would be right in there, submerged also, for the fish ladder entrance. The fish ladder is right there, going up to the canal. Flushing channel beyond, and one last pan of the structured cresting from this left side. A big piece of mystery trash clump hung up right there, huh? Man, what a ride. right above the training wall there. Todd Barranca beyond. This confluence of the Santa Clara River right there. Right there, actually. These Edison towers are new and were done during the construction of our project here. Bank protection installed along the riverbank, protecting the canal, which is on the mountain side of this. Well, here we are again. This is the Freeman Diversion project. This is downstream of the improvements that we just looked at, and this is a conveyance canal to the old headworks. Flowing pretty good, about 400 second feet. This looks like it's got 2.5–3 feet of freeboard to the concrete and additional on top of that. Capacity of the canal running clean is 1,000 second feet. I'm standing on a wildlife overshoot. You've probably noticed the fences around everything. PCL truck, that's the contractor that built the Phase 2 facilities, the diversion dam and fish ladder and all. This Phase 1 stuff was constructed by Roy E. Ladd out of Redding, California. That's this canal and some other stuff we're going to look at. This overshoot is required by Fish and Game and the fencing around the canal to prevent accidental drownings of wildlife. We have some use of the thing. Looks like maybe some coyotes or something. We'll get back a ways and take a better look at it. It functions doubly as a wildlife crossing and a drainage for these arroyos that wash down off of South Mountain. So using them as a wildlife crossing, there's a ramp here. You can see in the background there, and then ramps up onto the road. Then there's a 3-foot underpass, as it were, structure, and then the drainage continues in this trap canal out through the riprap and back into the Santa Clara River. Okay, this is the downstream terminus of the approximately 4,000 foot long connecting canal. Which was constructed to provide for the necessity of building a lower crest to the diversion structure. Water flow is in the direction of the camera pan. And down here there are 2 wasteways back to the river. This being the first one is newly constructed and consists of 2 sluice gates which rest on a lowered portion of the canal, which sweeps in continuity back upstream. Flushing through those can flush the canal and sweep the bedload back to the river. This lining was done with an interesting construction technique where they air jetted not gunite but actual designed concrete with a 3/4 inch aggregate, and then screeding up the slope, the relatively low slump air forced concrete. These are the old wasteways. These were constructed in the 1954 district-wide capital improvements project. 2 radial gates, and they likewise waste back to the river bottom. And these are the diversion pipe intakes, and from here the diversion water flows through pipes. These drop structures, weirs as it were, with trash racks on them. This flows into an 81-inch pipe, was constructed in the 1954 project. And next to it there is, boy, which one's that? That's the 42-inch pipe that was constructed in the late 20s by Freeman. And then the one at right angles here, this structure is a 42-inch gate flows into a 60-inch reinforced concrete pipe, 2-foot joint lengths, that was built by the WPA. And into each of these three, let's see if I can zoom in on one. There's an injector nozzles, which is that pipe that crosses right in the middle of your screen with T's and small pipes dropping out of it. Through these injectors, we can inject chemical flocculants to allow for the coagulation and sedimentation of the muddy river waters, and allows us to perform our groundwater recharge operations without plugging up the ponds. Now I'm going to pan over. The source of the material for injection comes from this building here, and we'll go in and look at some of the facilities inside of there. Okay, this is inside the flocculation building, and we're looking at a concrete block wall. There's two fiberglass tanks, over 7,000 gallons capacity each, which would hold the polymer. This is the sight tube in one of them. We're out of polymer at this point, and so we're taking the focus here. Take the river water in to the desilting basin without making too much of a mess. And this polymer is drawn out of the tanks and mixed with river water through these pumps and injected back into the three gates that we saw out there, the drop structures, through those injectors. And here's the three pipes going out to there, right here, and from the three pumps. We'll take another look at that here. Walk on around. Chemical mix pumps for feeding. Transducer setup. This contraption on the wall is a monitoring setup for measuring temperature, pH, and conductivity, turbidity of the influent, which is mixing with the polymer and going back out. And here's the second of the two tanks, and the first one that we saw. Panning around, just the door banging. Bathroom, handy. This is the control panel. Pan back a bit. Incoming data is processed here, and the flocculant rates adjusted. The data is measured both by these contraptions on the wall behind, as well as in a second building down at the inlet to the settling basin at the termination of those pipes in which the water was flowing through. And walking back around, the plumbing out of the tanks all plumbs in these channels beneath our feet here, so you can see, and back around to the pumps. And then likewise, you don't like to leave this stuff sit in the tanks all year without moving it around some. So there's a plumbing network from the bottom of the tanks and back up and pours it into the top so that we can, panning a little faster, we can mix the stuff up and keep it fresh. I don't know why our guys have some heaters set up in here. This is a high capacity screw pump for doing that, also for offloading the trucks of polymer, which can, where that stubs out on the other side of the walls where the trucks can hook up to put the polymer into the system. That's the pump. I go ahead and get the spec sheet on the polymer on the film. This is the, get a good focus here. I can't read it through this little screen here. I don't know if you can on the TV. And I'll pan on down, sight tube. There. And there's the mixing pump, influent pump. Might also notice that the doorways have stairs in and out on both sides, and that is so that the building itself serves as a tank should one of the big fiberglass tanks fail and release a rather caustic polymer. It wouldn't get out in the environment. We could deal with it right here in the building. Did want to get a picture of this. This is the old method of determining the turbidity of the water. These test tubes have calibrated amounts of silt in them, and the operator would grab a sample from the river, shake these test tubes up, and compare and determine whether to divert or reject the water. It's on the steps leading into the flock building, and there's the box where the trucks would back up to unload their polymer. Getting a battery line. Well, this is worthy of a shot. This is SP Milling mining the mountain property of Jim Lloyd Butler, or Lloyd Butler Trust rather, for top fill of the coastal landfill dump run by Ventura Regional Sand downstream. You can see they've had some erosion problems. They've built these levees right here to protect us from the runoff. Well, I can't see the levees very well, but that's part of it right there in the center, the screen. And you can see it makes a pretty big mess. But I thought we ought to... This is the outlet of the settling pipes, diversion pipes. There were 3 intakes up there. 2 of the older pipes join midpoint, and these 2 outlets come down. This concrete structure here is all new, part of phase 1 construction. These gates lead the water under the road and into the settling basin beyond. And I'm standing on a gate structure now which leads down to the old canal and old diversion canal to the Satakoy Headworks. That building here we'll take a look at has some equipment in for sensors for sensing the muddiness of the water and adjusting the polymer injection. Here's the other gate, and we're panning rapidly. We got a battery light on. Downstream, the old canal. This is just standing water, it's not flowing. Side of the road, and here's the water coming out from the new gates. Pretty muddy stuff. And it flows along, and newly constructed piece of canal and then down through these long baffles. And the purpose of this is to thoroughly mix any injected polymer. The mixing time is important in the flocculation process before it empties into the settling basin. This is a structure we call the long wall. It has differing baffle geometries along its length. We'll take a look at it from the other side. And then this timber wall is designed to be portions of it removed if necessary to even out flows and make the stuff mix properly. Okay, I'm standing at the end of one of 3 finger dikes in the settling pond and looking back at the long wall. That's Jim Lloyd Butler and Wes Hertel in the car over there. S.P. Milling's mining operations behind. The long wall mixing the water as it's flowing into the desilting pond from out of the canal. I'll do a nice pan around the whole desilting facility. Quite a nice body of open water. See some snow in the mountains there. Pretty day. And this here we're looking at is the spillway. Should the outlet become plugged or inadvertently shut, the thing wouldn't top these dikes. It would spill out this spillway back into the river. The Santa Clara River is immediately beyond there. And panning around, we'll see breezy today. The second finger dike is immediately beyond a structure right there. Is a drain whereby it has an outlet on the bottom. We can drain the whole thing. Water birds, of course, love this. And panning back around, continuing to looking towards the Pacific Ocean now. There's the radio towers. And that's the second finger dike. The third one's in the background. And we're panning. And right there is the outlet. Okay, we're at the outlet of the settling basin. The battery's going out on this camera. But this is the outlet structure. 2 gates. United's road. Under the road into the old canal. And you can see that old stretch of canal that I showed from before isn't live water, it's just dead standing water there. You can see the water is much clearer after getting out of the settling basin. We figure we have 150 cubic foot per acre foot sediment load right now flowing in that water that you saw, and this is about 10 cubic foot per acre foot water flowing out. And of course this water continues on down to United's recharge ponds. And I'll stop there too if this battery holds out. Okay, and this is where it ends up. The Satakoy recharge facilities. The diversion and canal are all up there along the toe of that mountain. And the settling basin's right about where I'm looking there. In fact, I think that's the outlet structure that you see right smack in the center of the screen. And it runs along a canal that runs through the middle of the grounds here. And I'll pan on around. Waterfowl, love it here. Canal's right on the other side of that first berm you see across the water. Lens cap out of the way. And more recharge operations. This water percolates in. Now that there in that building, tan building, is moss screen facilities and is the headworks for a pipeline system that runs out into the plain to one other recharge ground and to direct agricultural deliveries, including Pleasant Valley County Water District. That is some rotary drum screens, 3 of them, total capacity 200 CFS. Recharge grounds way out in the highway out there is 118, California 118. And the road. Hey, we're out on the right abutment of the Freeman diversion structure. I just looked at the staff gauge. There's 1.1 feet cresting. Standing on the right training wall, kind of precariously, so if the picture's a little funny. And there's the new headworks over on the other side. I'll get some better shots of that to get a better angle here. The wind's blowing. That funny bump that the water takes is due to RCC overbuild. You can see some rather interesting standing waves on the crest. Right there in the center of the picture's one. At different flows, they occur in different places. This is a better vantage point for the standing waves. You can see there's one. The water accelerates when it hits the concrete crest, is about 12 feet wide, and so about 12 feet back you see one where the water suddenly gets shallower, and it has some standing waves before launching off the lift there. Let's zoom in on the new headworks across the way. There's pretty heavy wind and the mist is coming up off the spill. Flushing channel, fish ladder outfall, entrance, as the fish people say, where the fish could enter. And there's the trash rack we saw earlier, and on upstream. I'm going to pan around here and show some of the new levees. We constructed up to where those weeds start right past the Bronco. It's all new, and then that's a new levee that the Bronco's on. That facility right there with the flap gate is an extension of an existing drain for the orchard behind the levee, and its flow comes out and joins Todd Barranca, which is running down this way. We'll take another angle on this. Turning though, I'm trying to do 360 standing on a wall here. That's Todd Barranca coming out and joining the Santa Clara. Take another. Well, this is equally precarious, but we'll get a good shot of Todd Barranca sweeping down. Now this diversion structure, the RC roller compacted concrete, is underneath us right here. This earth is fill on top of it, and it's down there to stabilize Todd Barranca. This small levee right there behind that concrete wall you see sticking up is to make sure that Todd Barranca doesn't eat around its way around off the RCC, thereby allowing the head cutting of the river downstream to progress up around, destroying levees and making the river end run across that farmland. There's Edison's new pole line that was constructed during the project construction, and I'm standing on a pretty high wall here in the wind, and there we're looking at the big hole from the excavation and the spilling diversion again. We went through 360.